Well, here's a second chance for you to get a plexer right. Let you pause that if you want to. I'm gonna say the answer right now. It is feeling under the weather. Maybe you got it. Feeling under the weather. Only the clever get those. I kind of like that one. All right, so here we go. Page 2, part 2. This sum and difference rules. And this basically says this is really not that big of a deal. It's kind of common sense when you start getting into these. The derivative of a sum, right here, it's the derivative of a sum is the sum of the derivatives, and also the derivative of a difference is the difference of the derivatives. And maybe that's not such common sense, but actually, like I said, though, once you get into these, you start understanding why they are what they are, and then we'll do a couple examples, and hopefully it makes sense. Okay, so this first one, A, we have y prime equaling, or sorry, we have y equaling x squared plus 5x minus 3. So in other words, we can take the derivative of each separate term and then just put it all in one and be done with it. So the derivative of y, or y prime, is equal to the derivative of x squared, which is 2 times x to the first power, plus the derivative of 5x. So that's 5x to the first power. So we have 5 times 1 x to the 1 minus 1, which is x to the 0. Remember, the derivative of a linear function as a constant. Okay, minus the derivative of a constant is 0. Okay, and so let's clean this up a little bit. It would be 2x plus 5. Okay, that's the derivative of y, or well, that's y prime. Okay, and after seeing that, I don't think you'd have too much trouble on this next one. So let's go ahead and let's do C. Okay, so C, I'm going to rewrite this here as 4x to the negative 1 minus 4x to the negative 2 plus 4x to the negative 3. This one's kind of a pain, but nevertheless, y prime equals, we have negative 1 times 4, which is negative 4x to the negative 1 minus 1, or negative 2. Okay, then we have this minus 4 times the derivative of x to the negative 2, which is negative 2x to the negative 3, okay, plus 4 times negative 3x to the negative 4. So the derivative of x to the negative 3 is negative 3 times x to the negative 3 minus 1, which is negative 4. Okay, let's see if we can clean that up a little bit. That would be negative 4 over x squared. Okay, minus 4 times minus 2 is plus 8 over x to the third. And then we have 4 times negative 3, which is negative 12 over x to the fourth. That's kind of a pain, as I said. Okay, well, there's not a lot of room for this d over here. So I'm going to just spare you, not make you do that one. 2x minus 3. I want you to try to, well, let me just tell you, multiply these two out, multiply the two binomials out here for part E, and then take the derivative. Okay, so if we do square 2x minus 3, we get 4x squared, and then minus 6x and minus 6x is minus 12x, and then negative 3 times negative 3 is a positive 9. So that's what f of x is, and I want you to go ahead and pause the video and do f prime of x. Okay, so f prime of x is 8x minus 12, and that's it, 8x minus 12. Okay, and then do the same thing over here. No, we're not going to do that. Okay, so we're going to skip on down to the product rule. Product rule, you use these all the time, by the way. The product rule, unlike the sum and difference rules, whereas the sum and the difference rules are the derivative of a sum is the sum of the derivatives. Same with the difference. However, please take note, the derivative of a product is not the product of the derivatives. Okay, so the derivative of a product is the first times the derivative of the second. Okay, and so I'll put the derivative in yellow. So the first function times the derivative of the second function plus the second function multiplied by the derivative of the first function. Okay? And so the derivative of the first function is right there. So let's go ahead and do one. I'm not going to make you multiply this out on your own. I'll do this. I'm going to do it with the product rule, without the product rule. So with the product rule, y prime would be equal to the first function, 4x minus 2x squared, times the derivative of the second function. The derivative of the second function is the derivative of 3x, which is 3. Okay? Plus the second function, 3x minus 5, multiplied by the derivative of the first function. The first function here is 4x minus 2x squared. The derivative of 4x is 4, and the derivative of negative 2x squared is negative 4x. Okay, 2 times 2 is 4, x to the 2 minus 1. So you get that. And yeah, this is kind of a pain. We can distribute the 3. 3 times 4x is 12x. 3 times negative 2x squared is negative 6x squared. And then plus, we could FOIL this out. 3x times 4 is 12x. 3x times 4x is negative 12x squared minus 20, and then plus 20x. Combining like terms, what a pleasant problem this is. Negative 6x squared, negative 12x squared is negative 18x squared. We have 12, 12, and 20. So 24 and 20 is 44x, and then we have minus 20. Well, that's pleasant. Okay, well, let's go ahead and multiply it out, and let's see what we get if we don't use the product rule. And you might be saying, well, if we can do this, why would we ever need the product rule? Well, trust me, you're going to need the product rule because you're going to get functions that you can't just multiply out. You're going to get things like the derivative of e to the x times cosine x. So e to the x cosine x, you have to use the product rule here. You can't just multiply those out because they are multiplied out. Okay, so trust me, you will have to use the product rule, and we just kind of practice the product rule on the only kinds of functions that we know how to find the derivatives of. And so here we go. Multiply these out, we get 12x squared, and we get, what do we have? Minus 20x, and we have minus 6x cubed, and then we have plus 10x squared. So plus, let me write that under here, that'd be good. So plus, oh no, what did I do wrong? There's got to be something wrong. No, I guess that's okay. So actually y is equal to, let me write it in terms of the order here. So we've got negative 6x cubed plus 22x, and then minus 22x squared minus 20x. And so once you do multiply it out, it actually becomes an easier derivative, because then we just take the derivative of the first term, negative 6x to the third, which is negative 6 times 3x squared, plus 22 times the derivative of x squared, which is 2x, and then the derivative of negative 20x is negative 20. Excuse me. And so we get negative 18x squared plus 44x minus 20, and that's exactly what we got over here. So two different ways to do the same problem. Good grief. Part C? No way. Well, let's just do some of those problems on Monday. I don't want to have you guys do that. That's a nightmare. Basically, I don't want to do that. I don't want to make you guys do that. You're never going to have to do a problem that big like that. That's a nightmare. Okay, so quotient rule, last one, and then I will be done for the night, and we'll finish the rest of this up on Monday. Just wanted you to get the basic rules, and then we'll apply them on Monday. Okay, so the quotient rule is kind of a cool rule, and there's a little mnemonic that I don't know if I've created it or not, but I think somebody told it once to me years ago. The derivative of the quotient of two functions f and g can be found by using this formula. F of x is the numerator and g of x is the denominator. Okay, So notice here we have the, and this is like the high, the one, okay, so this is the numerator is the one up here obviously, but we call it the high. Okay, I'm getting to the mnemonic here, little saying helps you remember. And then down here is low. Okay, so g is the function that we represent, or that we call the low function, and f of x is the function we call the high function. Okay, so this is the low function, or g of x, so the denominator times the derivative of the numerator, minus the numerator times the derivative of the denominator, all over the denominator squared. And so we have low d high, in other words, the low times the derivative of the high, minus high d low over low squared. Haven't really found a good way to think of that. But low d high minus high d low. We say low d high d low. Low comes first, d high minus high d low. It is important, and in contrast to the product rule, the product rule doesn't really matter if you take the derivative of the first times the second, or the first times the derivative of the second. It doesn't matter because there's a plus sign in between. But in the quotient rule, there's a minus sign, so order does matter. And so anyway, low d high d low over low squared. So let's try. Over here, we have derivative of this quotient is equal to low x squared minus 1 times d high. Now, we're going to do these in our heads here a little bit, so we're going to save a little time. But the derivative of this numerator, derivative of 5x is 5, and the derivative of 2 is 0. So low d high minus high, which is 5x plus 2, d low, and the derivative of the low, or the derivative of the denominator here, would be derivative of x squared is 2x, the derivative of negative 1 is 0, okay, all over low squared, x squared minus 1 squared. Okay, and I will have you do, let's have you do B. Okay, you do B, and we're done. Okay, done for the night. And pause the video, and I'll just go ahead and do it. All right, so we have low, x squared plus 4x minus 2, d high, which is 5, minus high, which is 5x plus 3, d low, which is 2x plus 4, and all that over low squared. Okay, I'm getting kind of lazy here. It's pretty late, and I'm not simplifying the numerator, but we could simplify the numerator. But I just would really like you to focus on finding the derivative. That is low d high minus high d low over low squared. Got it? Okay, so that's it. No other work. Just 2 videos, half hour. That's it. Have a great night. I'll see you Monday.